Hello all, welcome to the lecture series of spectroscopy. We are in the series 6. Earlier we were discussing about the electromagnetic radiation, the behavior of light, and the principle of ultraviolet spectroscopy. As a continuation of this, we can recap those things and we go for the instrumentation of ultraviolet spectroscopy. So basically, the spectroscopy is related to interaction of light with matter. We saw that the electromagnetic radiation at the wavelength 200 to 400. Above 400, it is called visible. So 200 to 800, when it interacts with the matter, that means the chemical substance or atoms and molecules, what happens? The light is absorbed by the matter. The result is an increase in energy content of the atoms or molecules. When the ultraviolet radiation are observed, this results in the excitation of the electrons from the ground state towards the higher energy state. When this happens, the molecules containing the 5 electrons, or we call it as non-bonding electrons, that is N electrons, can absorb energy in the form of ultraviolet light to excite these electrons to higher antibonding molecular orbitals. These have been explained by the Beer-Lambert's law and the excitation principles. The more easily excited the electrons, the longer the wavelength of light they can observe. There are 4 possible types of transitions we discussed earlier, here in which 5 to 5 star transition, N to 5 star transition, sigma to sigma star transition, and N to sigma star transition. Here the sigma to sigma star transition has a very high energy, and N to 5 star transition has very low energy. The absorption of ultraviolet light by the chemical compound will produce a distinct spectrum that aids in the identification of several compound structures. So now we come to the part of instrumentation. This is a simple block diagram of the instrument. So we have a light source, and the light enters through the entrance slit. Then there is a dispersive element. The dispersive element splits the light into several regions. So the excite slit selects a particular wavelength, allow into the sample container, and the sample container will observe some part of the radiation. Then the remaining light is detected by detector, and it gives the reading or the graph through which we can identify the amount of the concentration or amount of substance or whatever may be the things we discuss in applications. So this is a typical picture of the UV spectroscopy connected to a software. Once the analysis is done, they will get a software reading as a notepad. In the instrumentation part, the first one, as we said, is a light source. So a light source in a UV visible spectrophotometer should have a very few things, that is certain things to be considered for this. The operational wavelength range required for the application or where the sample's chromophores observes, the required light throughout, the stability of the source, the cost and lifetime of the source. So these things has to be considered while we selecting the source of light. And usually in spectrophotometers, deuterium or halogen light sources being used. The deuterium lamp is used for UV region between 190 to 350 nanometer, while the halogen lamp covers a much broader spectral ranges from 330 to 3200 nanometers. Both the deuterium and halogen lamps used are continuous sources. Although the D2, that is deuterium lamp, is also a line source, in continuous source, the arc created excites the molecules enclosed in the vacuum at a higher energy states. So considering these two, deuterium will be a better option. So as far as the instrumental part, in this session, we'll stop with the light source. And in the continuous next session, we will talk about the monochromator light, the emitter slit, exit slit, sample containers, and the detectors, types of detectors which we use. Thank you.